Hello everyone, welcome on our YouTube channel Physics Made Easy Kota. In this video lecture, we are going to understand about the alternating currents, and here are some topics which we are going to discuss in this video lecture one by one. So today we are going to understand about the LCR circuit. So an electronic LCR circuit consists of a resistor, capacitor and inductor, all connected in series combination with each other. Since all the three elements of the LCR circuit are connected in series, the current passes through them is the same. The LCR circuit also used to enhance the voltage or increase the voltage passing through the individual component of the circuit. This voltage can be much larger than the external voltage applied to the circuit. So it can be useful in various aspects, like it is useful to change the impedance of the circuit, to increase or decrease the resistance to the current of different frequencies. The three components of an LCR circuit work together to produce different effects. First of all is a resistor. Resistor limit the current flow through it. It helps in controlling the voltage or power that is applied to the LCR circuit. The resistor is a component of an electronic device that limit the flow of electric current. It also helps to control the amount of the voltage that is applied to the LCR circuit. Whereas capacitor store energy and release it in a controlled manner. It also helps in controlling the voltage or a power which is applied to the LCR circuit, as capacitors store energy and release it in a controlled manner, which further prevent too much current from flowing through the resistor. So inductor, it resists the change in current which is flowing in the circuit. It helps in controlling the fluctuation in the current flow. It also resists the change in the current flow, which helps to stabilize the LCR circuit. So as the all components are performing their respective roles, so LCR circuit has various applications. LCR circuit is used as a part of the electronic devices such as cell phones, that is of mobile phones, televisions, computers, to regulate the intensity of light emitted from these devices. So the LCR circuit having all these three components, and they are connected in a series arrangement, and alternating voltage is supplied. So in such arrangement, the current provide passage through all the elements of the circuit equally, and they have the respective voltage, that is a VR, VC, VL. This symbolize the amount of the individual voltage across the resistor, capacitor and inductor. So now we are talking about the importance of LCR circuit. It is important in various applications. LCR circuits help reduce power consumption by controlling too much current flow through a device. It also helps to reduce the voltage fluctuation that can damage electronic devices, store energy and release it in a controlled manner, which prevent too much current from flowing through the resistor. So in this way, it helps in controlling the fluctuation of the current flow, which stabilize the LCR circuit. There is a difference between the resistance and the impedance, as both means the opposition to the flow of the current, but resistance is the opposition offered by a circuit to the flow of the steady electric current, that is in a DC, and it is independent of the frequency. Whereas impedance is a measure of the opposition offered by a circuit to the flow current when alternating voltage is applied to the circuit. As both have the same units, as impedance has a unit and dimensions of the resistance, because we generally specify the opposition by the circuit. What is an LR circuit? An inductor resistor circuit is a combination of resistors and inductor. So these two components, resistor and inductor, can be connected into series or parallel. So the LR circuit are of two types, series LR circuit and parallel LR circuit. In series LR circuit, the driving source of circuit is voltage, whereas in a parallel LR circuit, the driving source of voltage is current. Actually, they are commonly used as the passive filters. RC circuit is a resistor capacitor circuit. This circuit consists of the components which are majorly resistor and capacitor. Along with these components, the RC circuit comprises a voltage source or current source which are responsible for the working of the circuit. The RC circuit can contain any number of resistor and capacitor. This number is independent and changes according to the need of the electronics. An RC circuit comprises only one resistor and one capacitor is called first order RC circuit, which is the simplest one. These circuits are used in various applications, mainly in filters, where they are used to block some range of frequency signals and allow only certain range to pass through them. Electrical resonance occur in an electrical circuit at a particular resonant frequency, where the impedance or the admittance of the circuit element cancel each other. Actually, resonance is a phenomena in electrical circuit where the output of the electrical circuit is maximum at one particular frequency, and that particular frequency is known as a resonant frequency. So at a resonant frequency, one condition is important, that the capacitive reactance and the inductive reactance in LCR series circuit is equal. So in an alternating current, if the phase of the applied potential voltage difference and the current flowing through the circuit is same, then that circuit is a resonant circuit, and the phenomena shown by these circuit is called resonance. LCR series circuit is one of the type of the resonance circuit. So now we are talking about the power consumed in an AC circuit. Power is given by the expression P is equal to IV, where I denotes the current flowing through the circuit and V is the voltage across it. AC circuit always offer reactance, therefore there are the two components of power, a power component because of the magnetic field and another because of the electric field. The average power absorbed by the circuit become the sum of the power stored and returned through a complete one cycle. Thus the average power consumed by a circuit will be the instantaneous power within one cycle. What about the power factor? Power factor is defined as the ratio of the true power flowing through the circuit to the apparent power present in the circuit. It is usually in the interval of -1 to +1 and it is dimensionless. So here are the formulas for the power factor. The quality factor, or known as the Q, is a dimensionless quantity. This describes the nature of the damping in a resonating circuit. It is indeed the ratio of the maximum energy stored in the circuit to the energy dissipated during each cycle of the oscillation. There are the various uses of the quality factor, like it helps to study the behavior of the mechanical pendulum, the resonating elements of the mechanical structure. So for electrical circuit, Q is defined as the ratio of the maximum energy stored in a resonating circuit to the energy supplied per cycle of oscillation by external source to keep the net signal amplitude constant. Whereas for the LCR resonating circuit, Q are the ratio of the resonating frequency and the difference in both frequencies, for which the power is half of its peak value. So transformers, an electrical device. This device can change the AC current. It is based on the principle of mutual induction, that is, by which the amount of magnetic flux linked with the coil changes, then an EMF is induced in the neighboring coil. So for the construction, we required a transformer, and for the transformer there is a requirement of the two coils. One is a primary coil, second one is a secondary coil. Both these coils are insulator from the ferromagnetic iron core. The source of an alternating current is required, and which is connected to the primary winding, and the output is obtained through the secondary coil, which is connected to the output resistance, that is also in a parallel combination. So when the ideal transformer we consider, then we consider that the resistance of the primary and the secondary coils are neglected. Transformers are divided into the two parts. One is a step up transformer, another one is a step down transformer. A transformer that increases the AC voltage is known as a step up transformer, and the transformer that decreases the AC voltage is known as a step down transformer. Also, an iron core is used because it is a ferromagnetic material which help in increasing the strength of the magnetic field. We know that the oscillations are divided into the two types. One is a damped, another one is a undamped. So here is a comparison chart which help us to understand what kind of the oscillations are called as a damped oscillation and what kind of oscillations are the undamped oscillation. So for the damped oscillation, whose amplitude decreases gradually with time, and undamped are those whose amplitude remain constant with time. So whereas the damped oscillation are such type of the oscillations does not continue for a longer time because their amplitude decreases and finally they come to the end or decreases, whereas the undamped oscillation, there are no power losses, no provisions to compensate for the power losses because their amplitude remains same, their amplitude does not change with the time. For the damped oscillation, the frequency of the oscillation remains unchanged because it depends on the circuit parameters, and damped oscillations die out eventually, but undamped oscillations will oscillate indefinitely because their amplitude remain constant. So now the last comparison is about their examples. So for the damped oscillation, the best example is a swinging pendulum in which the vibration slows down and stop over time, and for the undamped is a kid spring mounted horse with no interior restraint to resist the movement.